The universe is always filled with mysteries to humankind, especially when we gaze up at the twinkling stars and wonder, what lies hidden behind that dazzling beauty? For hundreds of years, the mysteries of the stars have remained intact because scientists could only observe the galaxy from Earth. To capture the image, light from space must pass through Earth's turbulent atmosphere, causing the image to blur and lose its original sharpness. Later, space observatories were built beyond Earth. Thanks to this, the most stunning images of the universe were captured. The vibrant nebula clouds adorned the dark, monotonous universe with a resplendent beauty akin to golden sunlight. What is a nebula? A nebula is a luminous region in the interstellar medium that may contain ionized hydrogen, neutral hydrogen, molecules, and cosmic dust. Nebulae are often star-forming regions. Here, gas, dust, and other materials come together, forming denser, more concentrated areas. The matter continues to accumulate and gradually reaches the necessary density to form a star. The remaining material then has the potential to create planets and other celestial bodies within the planetary system. Most nebulae are enormous in size, with some spanning hundreds of light years. If observed from Earth with the naked eye, the nebula would appear larger than it actually is. But they are not brighter when nearby. Although denser than the surrounding space, most nebulae are still far more tenuous than any artificial vacuum on Earth. A nebula cloud with a size comparable to Earth but a total mass of only a few kilograms. The air on Earth has a high density, containing about 10 to the power of 19 molecules per cc. In contrast, even the densest nebulae only reach a density of around 10,000 molecules per cc. Many nebulae can be observed due to the light emitted by the hot stars within them. Meanwhile, some other nebulae are so diffuse that these nebulae can only be observed with long exposure and special filters. Some nebulae are illuminated by T-Tauri variable stars. Nebula. For example, the Andromeda Galaxy was once called the Andromeda Nebula, and spiral galaxies in general were referred to as spiral nebulae. Before the true nature of galaxies was confirmed in the early 20th century through the work of Vesto Slipher, Edwin Hubble, and other scientists. Edwin Hooper observed that most nebulae are associated with stars and are illuminated by the light from those stars. He also assisted in classifying nebulae based on the types of light spectra they emitted. Some nebulae form from the interstellar medium, while others are created by the stars themselves. A prime example of this case is giant molecular clouds, the coldest and densest concentrations of gas in the interstellar medium, may form through the cooling and condensation process of various diffused gases. A prime example of the second case is planetary nebulae, which are formed from material ejected by the star in the final stages of its evolution. Star-forming regions are glowing nebulae, closely associated with giant molecular clouds. They form when a molecular cloud collapses under its own gravity, giving birth to stars. Giant stars can form at the center of galaxies, and their ultraviolet radiation ionizes the surrounding gas, causing it to glow and become observable at optical wavelengths. The region of ionized hydrogen gas surrounding hot young stars is called an H2 region. The neutral shell surrounding the H2 region is called the photodissociation region. Examples of star-forming regions include the Orion Nebula, the Rosette Nebula, and the Omega Nebula. Feedback from star formation processes in supernova explosions has stirred up an enormous amount of material. Stellar winds or ultraviolet radiation from massive stars stir the flow, while waves from smaller stars have a weaker impact. Capable of tearing apart gas clouds and annihilating nebulae in just a few million years. Other nebulae are formed from the explosions of supernovae. Massive stars with short lifespans often meet a violent end. The materials ejected from the supernova explosion were then ionized by the energy and compact object produced by its core. A prime example of this is the Crab Nebula in the constellation Taurus. The supernova event SN 1054 was recorded in the year 1054. The compact object formed after the explosion lies at the center of the Crab Nebula, and now, its core has become a near-dwarf star. There are other types of nebulae as well, such as planetary nebulae. This is the final stage in the life cycle of a low-mass star, like our Sun. Stars with masses 8 to 10 times that of the Sun. The star evolves into a red giant and gradually loses its outer layers due to pulsations in its own atmosphere. When a star loses a sufficiently large amount of material, its temperature rises, and the ultraviolet radiation it emits can ionize the surrounding nebula previously expelled by itself. The Sun will form a planetary nebula, and its core will remain as a white dwarf. Nebulae are vast clouds of gas and cosmic dust scattered across space. They exist in various forms, including emission nebulae, which glow on their own, reflection nebulae, which reflect light from nearby stars, and dark nebulae, which absorb light, creating dark patches against the starry background. Each type of nebula has its own distinct features, contributing to the universe's mesmerizing beauty. Diffuse nebulae. A diffuse nebula. This is the most popular type of nebula. Diffuse nebulae are clouds of gas and dust without clear boundaries. They are generally divided into two main types, emission nebulae and reflection nebulae. An emission nebula is a type of nebula composed of gas and dust that glows when near massive stars. When strongly stimulated, it ionizes and emits light. The temperature at the center of these nebulae can reach 8,000 to 10,000 degrees Celsius, with diameters ranging from several dozen to several hundred light-years. Reflection nebulae are nebulae that appear brighter than the surrounding space by reflecting light from nearby stars. This nebula consists of gas and dust clouds that are highly reflective. The light of this type of nebula is not as bright as that of emission nebulae. However, this type of nebula has a continuous spectrum because the emitted light is reflected light. An emission nebula has a spectrum consisting of bright lines, formed by the phenomenon of stimulated emission. Some nebulae are opaque clouds of gas and dust, so dense that they are thick. May obscure light from background radiation or reflection nebulae, or block the view of background stars. In the sky, they appear as dark shadows because nearly all the starlight shining toward them has been absorbed by the surrounding gas. Dark nebula. Planetary literature. Planetary nebulae are the remnants of low-mass stars in the final stage of stellar evolution. The stars evolved along the asymptotic giant branch, expelling their outer layers through powerful stellar winds. Thus, the gaseous envelope was formed, while leaving the star's core behind as a white dwarf. The radiant step from the hot white wind stimulates the gases to rise and escape outward. Create emission nebulae with spectra similar to those commonly observed in star-forming regions. The H2 regions are the areas most affected due to the dominant heterozygosity process. But planetary nebulae are denser and smaller in size compared to the typical nebulae found in star-forming regions. The planets were named by the first astronomers who observed them. At first, they couldn't be distinguished from planets. And those who often mistake them for planets, the things they're actually more interested in. About 12 billion years after its formation, our Sun is expected to create a planetary nebula. Protoplanetary nebula. A protoplanetary nebula is a type of astronomical object that exists for a brief evolutionary stage. In the rapid stellar evolution phase, when a star at the end of the asymptotic giant branch transitions into the subsequent planetary nebula phase. During the AGB phase, the star undergoes mass loss, forming an inhomogeneous gaseous shell around it. When this phase ends, the star will transition into the protoplanetary nebula stage. These objects are powered by the central star, causing them to emit strong infrared radiation and become a reflection nebula. The wind emanates from the central star with precision, shaping and impacting the shell, giving it an axisymmetric form. At the same time, it generates a molecular wind moving at high speed. The exact moment a protoplanetary nebula transforms into a planetary nebula is determined by the temperature of its central star. The protoplanetary nebula phase continues until the central star reaches a temperature of 30,000 degrees Celsius. Then, it becomes so hot that it can ionize the surrounding gas and turn into a planetary nebula. Supernova remnant. A supernova is a phenomenon that occurs when a massive star reaches the end of its life cycle. When nuclear fusion in the star's core stops, the star will die out. When the gas enters inside, it either bounces back or is heated so intensely that it expands from the core outward. So, make the star explode. The expanding gas shell forms a supernova remnant, a special type of diffuse nebula. Although most of the optical and X-ray radiation from the supernova remnant originates from ionized gas, a large amount of radio radiation is a form of non-thermal radiation, known as synchrotron radiation. This emission phenomenon originates from high-speed electrons oscillating in a magnetic field. The connection between nebulae and stars. Stellar nebulae play a crucial role in the life cycle of stars. Even when they are born or fade away, stars are formed from dense clouds of gas. The dust and other materials in the nebula emit diffuse light, and these types of nebulae are often called stellar nurseries. Philos of Gryson, captured by Huber, is also a master player in this field. Additionally, the Orion Nebula is one of the most famous nebulae. You can easily observe this nebula yourself with a regular telescope if you know how to use it. This causes the interstellar environment to continuously condense into nebulae. And gravity causes the clumps of matter within the nebula to collapse, forming stars. When a star reaches the end of its life, we often observe a special type of emission nebula. At the end of their life cycle, Sun-like stars typically evolve into white dwarfs. But before turning into streaks of white shooting stars, they will release vast clouds of gas and form planetary nebulae. Unlike diffuse emission nebulae, these nebulae have a more distinct shape. Usually circular in shape, and it was precisely this characteristic that caught the attention of William Herschel, the German-born British astronomer. At first, he mistook them for planets when he first observed them in the 1780s. However, not every star has such a smooth and uneventful life cycle. When a star has a mass many times greater than the Sun, at the end of its life cycle, it will end in a supernova explosion. The explosion ejected debris, forming a special type of nebula known as a supernova remnant. The most prominent among them is the Crab Nebula, or Crab Nebula, recorded by Chinese and Arab astronomers in 1054. To capture the vibrant images of the nebula, scientists use modern telescopes, such as the Hubble Space Telescope. And the James Webb Space Telescope captured the image by detecting the infrared radiation emitted by the nebula itself. This light is produced by stars forming within and around the nebula. It may be obscured by dense clouds of gas and cosmic dust, forming a nebula. After that, scientists need to continue studying other wavelengths of light emitted by the nebula, such as infrared wavelengths. Some nebulae are very familiar to us. The G-Fit Nebula is located in the Sagittarius constellation. The name G-Fit means it is divided into 3 branches. This nebula is a combination of emitted nebulae. Below is a crimson expanse, with shimmering stars. Above lies a blue stretch dotted with tiny stars. The rays of light emitted from the nebula give it a 3-branched shape. HOSHIT, also known as the Horsehead Nebula, is a dark nebula located in the constellation Orion. It is about 1,500 light-years away from Earth. This is one of the most recognizable nebulae due to the unique swirling shape of its gas and dust cloud, which looks exactly like a horse's head. The Helix Nebula is not only one of the most beautiful planetary nebulae but also utterly mesmerizing. It is also the closest nebula to Earth, located just about 710 light-years away from us. The Cone Nebula is located in the constellation Monoceros and was discovered by William Herschel on December 26, 1785. It is located 2,600 light-years away from Earth. The Cone Nebula is a type of reflection nebula. Beneath the blue glowing nebula lies the Sac Nebula. The Eagle Nebula is a nebula located in the constellation Serpens, formed from an open star cluster, collaborating with an emission nebula containing hydrogen atoms. This distance is not precisely determined, but astronomers generally estimate it to be around 7,000 light-years. The Cat's Eye Nebula, NGC 6543, is a planetary nebula located in the constellation Draco. Structurally, this is one of the most complex nebulae ever observed. The Hopper Space Telescope has captured axial images, revealing structures that resemble knots. The jets or plumes were discovered by William Herschel on February 15, 1786. The Carina Nebula is one of the largest and brightest nebulae in the night sky. Located 7,500 light-years away from us in the Carina constellation. It is 4 times larger than the famous Orion Nebula and boasts far superior brightness. The Omega Nebula, also known as the Swan Nebula, is located in the constellation Sagittarius. The Omega Nebula is located about 5,000 to 6,000 light-years from Earth and has a diameter of approximately 15 light-years. The Lagoon Nebula is a cloud of gas and dust located among the giant stars in the constellation Sagittarius. It is classified as an emission nebula. The Lagome Nebula was discovered by Zulome Lucentine in 1747, and is one of the two nebulae faintly visible to the naked eye from mid-northern latitudes. The Crab Nebula, also known as Messier 1, is located in the constellation Taurus. This is also the remnant of the supernova SN 1054, also known as the guest star. This nebula was observed by John Bevis in 1731. This passage corresponds to the brilliantly bright supernova observed and recorded by Chinese and Arab astronomers in 1054. NGC 6302, commonly known as the Butterfly Nebula, is located in the constellation Scorpius. It is located about 3,800 light-years from the star Scobius. The wings of this giant butterfly span over 2 light-years, equivalent to half the distance from the Sun to the Alpha Centauri star system. The Orion Nebula, also known as Messier 42, is an emission nebula with an apparent location in the constellation of Orion. In 1610, French astronomer Nicolas Claude Fabry de Peyresque discovered this. This is one of the brightest nebulae visible to the naked eye, located 1,500 light-years from Earth. The Eskimo Nebula is located in the constellation Gemini, approximately 5,000 light-years from Earth, and was discovered by astronomer William Herschel in 1787. Through ground-based telescopes, the Eskimo Nebula appears as a face-like shape enveloped in a hood, resembling the traditional attire of the Eskimo people. The traditional Eskimo hooded fur parka. The Rosette Nebula, also known as the Rose Knot Nebula or the Rosary Nebula, is one of the most beautiful celestial objects in the universe. It has a nearly round shape, located at the edge of a giant molecular cloud in the constellation Monoceros. This nebula is located about 5,200 light-years from the solar system and has an actual size of approximately 100 light-years.